For Team 17's design project, they've decided to go with a autonomous cooking utensil that will stir or mix any bowl or pot automatically without the need of dedicated assistance in order to increase safety, versatility, and flexibility in the kitchen. So starting off with our planning phase, the goal of the project is to reduce the incessant stirring or mixing needed that requires constant attention when you're constantly moving around the kitchen. So starting off with safety, this would help with safety because it would reduce the possibility of things like burns or cuts as you're running between tasks, constantly cooking. So going between a task like mixing a bowl on a stove to constantly keep it moving to keep things from burning, and then shifting between like slicing up any kind of other ingredient that you're doing as part of your cooking, and going back and forth between the two very rapidly can be dangerous. So being able to leave these unattended would open up many doors and possibilities for other options and windows to increase safety in the kitchen, as well as efficiency. If you're moving back and forth between many of those tasks at once, being able to shift some of those over to an autonomous machine so that it can do the rudimentary task on its own with minimal supervision would allow for monitoring of several different tasks at once without dedication to a single task. And finally, with flexibility, having the ability to swap out the mixer for different types of whisks, spatulas, forks, because all of them have different needs in the kitchen, would be very, very valuable. In terms of planning on the Gantt chart side of things, to keep the team on track, we decided to make a Gantt chart in MS Project. And starting off with where we are right now, we are currently at the identification of customer needs and establishment of target specifications, which was just recently completed. And eventually we will be working, the team will be working towards concept generation and testing in the upcoming weeks, and eventually in prototyping towards April 11th to 15th, and final results being presented around May 7th. So moving on to customer needs, the team interviewed about eight users, eight cooks, ranging from the everyday home cook to your self-proclaimed master chef, to get a good range of opinions and viewpoints on what a new kitchen utensil might need. From that, we were able to gather 5 critical points that we were to look at while designing, starting with versatility, intuitive and simple design, autonomy, customizability, and precision, and then inviting design. All 5 of those are going to be the main points that we are going to be trying to focus on as a team as we go into the concept generation phase. Each of these were also given criticality and uniqueness points after further evaluation, depending on how many times these interpretations were seen repeated, or or based on other sorts of use. So moving on to product specifications. To get these specifications, the team wanted to look at similar products that are currently on the market and compare and contrast them with what we were expecting to do versus what we should be doing in the future in order to make this a viable product. So comparing these to a lower tier product, this lower tier product has no customizable features, 3 stirring modes, and it tends to have issues with both balance and drift, and it tends to go for around $38.95. and it can be found on Amazon. This mid-tier product is sold independently. It only has 2 stirring modes, but does have some different compatibility with pots. No balance or drift issues as mentioned with the lower tier. But it does only have 1 attachment, and it goes for $55. Now with RevoStir, what we are planning to go with is a new kind of design that doesn't increase too much of the cost. So customizable stirring patterns. A microcontroller is already going to be in this. Customizable stirring pattern simply adds on to the coding work, which isn't a whole lot of physical material manufacturing, which shouldn't increase the cost too much. 3 different stirring speeds, which again is partially motor dependent, but it's also mostly code dependent. Having the ability to switch between those 3 speeds and use them efficiently. We also have we're also planning on 3 different stirring attachments, so, which is slightly different than both our low tier and mid tier product, so that we can have versatility on whether the product is going to be attaching to a bowl or to a pot or any different size because bowls can be as small as 6 inches in diameter and pots can be as big as a foot in diameter, if you really think about it. And stirring each of them in both a dry and wet environment can be very, very valuable. Also, a smart timer. This kind of thing would be a little bit more of a complex integration due to having an integrated display, but it would also help, that display would also be helping with our different customizable speeds and other features that might be more digital or coding based in order to inform the user of what exactly is going on with it when they're using it. So moving on to our quality function development. Once we put all of our customer needs in here, we were able to properly determine which functions might be the most, which functions should be focused on the most. And from the quality function development exercise, we were able to determine that the mass, durability, and adjustability should be our highest focus because of their difficulty to manufacture balanced with their technical importance. Because things like mass, there's only so much we can do to control that, but it's something that we really should be focusing on. It's something that we should really be focusing on to make sure that this thing, when you take it out of the cupboard, you're not being weighed down by it. Durability, things in the kitchen get dropped all the time. And up here we have it actually twice, drop test and water resistance. If this thing is going to be over a pot, it needs to be water resistant, steam resistant, heat resistant. If it's going to be in a kitchen, it needs to be drop proof, or at least drop resistant, so that any sort of situation where it is dropped, it is not going to immediately shatter and explode into a million pieces. And finally, adjustability, as I talked about that before, adjusting between different sizes of bowls and pots is very, very important. And for our economic analysis, taking a closer look at it, our estimated selling price would be around $68.99, which puts our product a little bit above our mid-tier product that we saw in the product specifications slide. Looking at it, if our break-even would be 435 units if our fixed cost is $10,000. And given our estimated manufacturing cost of $46, which you can see split up here in our cost breakdown chart, if we have a competitive profit margin of 50%, that then gives us our $68.99 that I talked about, that I mentioned earlier. So, and finally, for our summary, at an affordable price, this product would place itself into, would have multiple features that would definitely differentiate it from other products in the market, and at its price point would definitely be an interesting and worthy purchase. In terms of innovation, this would be targeted towards college students as well because of its versatility and tight budget, because it fits into that mid-tier range and not the super high tier range that you might see with some very, very expensive kitchen products. Financial feasibility, like I said, and mentioned in the previous slide, falls into that mid-tier. Data-driven development. We did interview several of the interviewees were students, so that falls into our scope of targeting students. And our competitive edge with the many features as mentioned in the product specifications and VQFD. And that's all that I have. Thank you.